Hey, I'm Emma, and let's start this networking part of our course by looking at 4 communication methods. The first 2 are serial and parallel, and the next 2 are synchronous and asynchronous. Integral to asynchronous transmission are start and stop bits. Let's begin by defining data transmission, which simply refers to the movement of data, either digital or analog, from one or more places to another, for example, from a computer to a printer. Data transmission occurs between a transmitter and a receiver across a transmission medium, which could be something like the air or a metal cable. The term communication channel refers to the connection between the devices. Data can either be sent in serial or in parallel. Let's look at serial transmission first. This is sending data sequentially, just one bit at a time across one wire. USB transfers would be an example of serial transmission. A USB stands for Universal Serial Bus. This contrasts with parallel data transmission, which is when multiple bits are sent simultaneously across multiple wires. A real-life analogy would be a single-lane road representing serial transmission, and a motorway with multiple lanes representing parallel transmission. You probably associate anything with parallel in it as always being the better option, but actually we need to talk about a few reasons why serial transmission is often preferable. The property you often analyse first is costs, so let's start there. Naturally, with serial, you only have one wire, whereas you have many with parallel. Not only does the actual cable cost money, but to deal with parallel transmission, you need more equipment, like specialised switches and ports. A more technical advantage of serial over parallel is the existence of something called skew. This is the tendency of parallel signals to lose their synchronization as they travel, causing some of the data to arrive at different times, when it's meant to be transferred simultaneously. This might happen because your wires aren't totally the same. Even a small discrepancy in the material can cause a skew that's enough to be problematic. A third great point to mention in an exam is the interference between the parallel wires. Crosstalk is a term that sums up the whole problem. It's when the electromagnetic disturbances of one wire affect the signal travelling in another. This interference between the wires can cause the data to be corrupted, meaning it has to be retransmitted. Basically, all 3 become more pronounced over larger distances, so parallel is only really used over smaller distances, like for a bus within a computer, whereas the data within a long-distance fibre optic cable, for example, would be transmitted serially. Right, let's move on to the second half of this video. Synchronous literally means occurring at the same time, and synchronous communication in real life would loosely be something like a face-to-face conversation because it's carried out at the same time without a pronounced delay. So, more formally, synchronous transmission is data transferred at regular time intervals because the communicating devices synchronize using a common clock signal. In case you haven't encountered a clock of the computing variety before, it's just a device that produces a repetitive signal which is used for timing purposes, like synchronizing the CPU. This can be as simple as regular voltage pulses, which we can represent with an alternating binary pattern. So in synchronous transmission, the transmitting device will send data in time with the clock signal, like only sending data when the clock signal is a 1. Asynchronous means not at the same time. A real-life example of asynchronous communication would be sending a letter, as you aren't permanently connected. In this context, where we are usually talking about internal computer buses, buses carry data and signals within a computer system. the transmitter and receiver don't use a common clock signal to synchronize. The only time they link is when the communication happens. A start bit initializes this. So to reaffirm, the devices aren't kept synchronized, but rather only at the time of transmission. By the way, you need the devices to be synchronized in the first place in order to prevent data from being lost if the receiving device isn't ready. I mentioned the presence of a start bit. This is literally the first bit sent, usually a 1, to the receiving device, which indicates the start of the transmission of data. Then follows the body of data, in this case a byte, followed by a stop bit, which indicates the end of a unit of data transmission. Instead of a common clock signal, the start bit causes the receiving device to synchronize its internal clock to the transmitting device's clock, ensuring they are in time. It is also important to appreciate that the number of bits in one transfer needs to be pre-agreed. Unless the devices are programmed to expect 10 bits, like in this case, then the start and stop bits might be incorrectly processed as data. Instead, the receiving device is expecting a byte, which is the actual data. If more than a byte needs to be sent, another start bit will have to initiate it, so the process repeats. The advantage of asynchronous transmission is that you can send data whenever it is ready, rather than having to wait for the system clock to align. However, you require 2 more bits to be sent than you would if synchronous transmission was used. Alright, let's recap. Serial transmission is simply data being sent bit by bit in a sequence, whereas parallel transmission is when data is sent along multiple wires simultaneously. Another way of classifying transmission is as either synchronous or asynchronous. Synchronous means constant synchronization between the two devices using a common clock signal, whereas asynchronous only connects them when a start bit arrives at the receiving devices and finishes when a stop bit arrives.